Hey, Adam here from Tested in My Cave, and today we're going to talk all about taps. A few weeks ago, I did a build in which I was tapping something, and I used a device called a tapping guide in order to tap straight. And a few people tweeted and wrote in the comments they were wondering what I was using, and so I thought I'd show you, one, how to make a tapping guide, two, how to make a tap and tap drill holder, which is a useful thing for any makerspace, and it's a great little project. And then lastly, I'm going to show you some of what I know about tapping. Tapping, for those of you who are uninitiated, is a process of using a thing like this to put threads into a hole so you could then screw a machine bolt into that hole. So this is a thread cutting tap made out of hardened steel, and tapping is a sort of dividing line for makers. Like a whole bunch of makers are terrified of tapping, and rightfully so. We'll talk about some of the pitfalls and the ways in which tapping can ruin your life. However, what you should know about me is that I love tapping. I find it super meditative and super relaxing. And yes, I've broken my taps and had to redo work because of it. But the mindset that tapping requires is one I find very pleasurable to tap into, and by the time I'm done with this video, hopefully you will too. A little tapping 101. A tap is a threaded rod with grooves cut out of it to allow the threads to obtain a cutting surface. So if you look really closely at this, you'll see where the grooves are carved out. They create this sharp edge on the tap, and what that does is that peels metal as it goes in, and as such, the entire tap is tapered. It's a little narrower, well, it's definitely narrow up here, and then it's narrower here than it is here, and this is to allow it to pull threads out slowly. Now, there are many different kinds of taps. If you're doing a blind hole, i.e. a hole you can't see through to the bottom of, you use a normal tap and then you use a bottom tap. And this is all stuff that we're not going to cover in this video. This tap specifically is a kind I love, which makes the job of tapping very easy, and it's called a spiral point. And if you notice this little interesting cut at the tip, so normally what happens with tapping is, as you are turning, these little edges are peeling parts of the metal out and they're curling up. And so the normal part of tapping that everyone was taught when I was a kid was that you turned one full revolution forward and then half a revolution back. And the reason you turned back was to clear the bits of swarf that you were creating inside the hole. With the spiral point, that's less necessary. I'm not going to say it's not necessary, because you can get into trouble, but it's less necessary because the specific angle of the cut up here pushes the swarf forward and out of the hole. And you're going to see what I'm talking about, but that's just the initial tap 101. The second part of tapping 101 is the tap wrench. And if you bought a tap set, which has a lot of crappy things in it, you'll have gotten a tap wrench that looks like this. And so what it's got is a pair of jaws here that can squeeze down and they can grab taps of various sizes. For most model making tapping, for most beginning makers, this should be your big tap wrench. This is for 1/4-20 and up. So this is a 1/4-20, your standard threading. This is a great tap wrench for a 1/4-20, but it's way too freaking big for a 632 like this. If you put this in here, and I'm not even sure you can get it in there, but you might be able to. Sometimes the tap sets come, yeah, it's not quite. At any rate, a big tap wrench on a small tap is a recipe for disaster, which is why the first thing I'm going to tell you about tapping 101 is this tap wrench right here, the Starrett tap wrench. And one of the reasons people don't like tapping is it's hard to get a good feel. This may end up needing to go later in the video, but I'm going to shoot it now anyway. One of the reasons people don't like tapping is because you're using a small tap like a 440 here, and you've got it chucked into a big tap wrench, and you can't quite feel the steel resisting you, and you go tap, tap, tap into your motorcycle tank, and it cracks. Freaking disaster. When you get one of these tap wrenches and it snaps, and they love to snap because it's super brittle steel, remember, because it's made for cutting threads out of steel, You get a piece of this lodged in something, and you can't get it back out again. You can, but it's a real pain in the ass. And so, in order to obtain feel from my taps, I use this little small Starrett tap wrench. Look at how beautiful this thing is. It's life-changing. And you go in, you'll see. I'm gonna tap later on, you'll see how nice a feel I get for how to use that tap. But I think I'm getting ahead of myself. I think some of this I'm gonna actually shoot inline as I go, but I'm kind of excited to talk about taps because again, I love it. Most people are afraid of it. I'd like less people to be afraid of it, so let's go. Here are the basic complements of taps that I have always had in my shop since the early 90s, and they have served me really well. I'm a believer that you don't need to go buy the full tap set. You should buy the taps that you need as you need them. You'll be buying higher quality taps because a lot of the times the ones you buy in the big kits aren't that great. And again, you don't need all the sizes. 256 is even arguable for most people. That's a very small screw. Most shops could get away with 440 as their smallest screw, but here's what we have. 256, that means a size 2 screw with 56 threads per inch. 440, size 4 screw, 40 threads per inch. Again, first number is the size of the screw, second number is the threads per inch. 632, 832, 1024, 1032, excuse me, and then quarter 20. Quarter 20 is the bread and butter. If you only had one tap, this would be it. So I think where to start is for me to drill a hole and tap it in front of you so you can see what the hell I'm talking about. So to drill this hole, I've got some really nice extruded 1-inch acrylic. I am going to make a couple slices on my table saw and maybe even flame polish this so you can see the tap happening as I'm going. It's really instructive. I'm using this acrylic educationally, which means I'd like to be able to see through it. And I could tap down like this, but I'm also gonna just smooth out this side. So I did a table saw cut with my triple kerf, with my zero kerf triple chip blade. I got a nice cut. I did a quick wet sand on 320 grit sandpaper. I have a nice smooth surface, and you'll see I'm gonna do a flame polish on this. It's gonna be right pretty. Bet you didn't know how efficiently a flame could polish the edge of acrylic, but yes, it does. It's not a perfect job, but it's not a perfect piece. Just kind of showing you a proof of concept. Great. All right, so again, if you're looking at the tap and you're doing an elevation drawing where you see these little zigzags, the drill bit describes the inside of the drill of the zigzags. For a quarter 20 tap, the correct drill bit size is a number 7. Now you know, you'll never forget. So we're gonna drill a number 7 hole right here, and then we're gonna tap it. I'm about to drill acrylic, and normally if you're drilling acrylic, you actually wanna use a different drill bit for acrylic. That's actually a whole nother video talking about acrylic drilling and stuff like that. For the purposes of this video, I'm doing a quick drill with a normal drill bit, which works just fine. Drilling acrylic works much better if you use a cooling fluid, and the only cooling fluid you need is water. So I'm gonna use some water while I'm drilling this, and you'll get to see. If the drill bit gets too hot, it's gonna start to melt the acrylic, and then all hell breaks loose. You don't want that. Yeah, I know you don't like to use water around the pieces of steel in your shop, but it's totally fine to as long as you wipe it off. A little WD-40 works great too. Now, we're going to tap this piece of extruded acrylic with a quarter 20 tap. Uh-oh, first problem is my super sensitive sweet Starrett tap wrench does not fit the quarter 20. Luckily, Starrett makes more than one size. We'll use a slightly bigger one here. Oh, look at that. Oh. I can't tell you how good a well-made piece of machinist equipment feels. First rule of tapping. This is a title of a chapter of my book, Use More Cooling Fluid. Use tap fluid. I love this stuff, rapid tap. Jamie used to have this stuff in his shop called Molly B. Molly-B. And it was called that because it had molybdenum in it. And it had the best ad copy. It was like from the 50s. It had the best ad copy on the can. It said, Molly B, the finest machining assistant yet devised by nature and the skill of man. The use of molybdenum allows an, quote, ever-present cushion of lubricity. Right? That was ad copy. Okay, so I'm gonna use a little rapid tapping fluid here. This just helps my cuts happen. Put a little bit in the side of the tap, and we're just going to start tapping. And again, as the blades of the tap start cutting, they start creating little bits of swarf, which the spiral point will send out ahead of the tap, and you should start to see those kind of start to form. Is that starting yet? Yeah, okay, cool. Now, again, even though this is a spiral point, I've had them break on me when I've overtaxed them. So you can't put too much tapping fluid on it. It's like you shouldn't be working too hard to tap, but I do about a half rotation and then a quarter back, and a half and then a quarter back, and then a half and then a quarter back. And you just get into this rhythm so that anytime you encounter real resistance, you're stopping, coming back. It's also allowing the tool to cool a little. Just peeling up material, you are carving through molecules and atoms, and that carving creates friction, and that friction creates heat, and the heat's what can screw up your hole. Now, you've seen me use drills for taps like this, and I certainly do for shallower material. For a 1-inch hole, I'm always going to do it by hand. You don't want to overheat the threaded hole that you're making. And again, just more tap fluid is even better. There we go. That is our tapped hole, and here you can see the bits of swarf that were cut, right? So that's little bits of acrylic peeled out of the sides. If you look into this thing, you'll see I've cut threads in there, and you'll see further when I take a 1/4 bolt, it threads really nicely. Oh, look at that. Isn't that glorious? That is just beautiful. Okay. That's the easy one. I know, you're all comfortable with the 1/4. What you're freaking out about is the 440, and I totally get that. We'll do a 440, but we're gonna do it in aluminum because we're gonna have this one have stakes. If I did the 440 in this stuff, you'd be able to see it, but it's acrylic, the stakes are low. Let's do it out of a chunky chunk of aluminum, and then you'll see how I attack that. I've got here a piece of thick wall square aluminum tube. So I'm gonna drill a 440 hole right through there. Now, I told you that I had memorized that a 1/4 tap drill was number 7. I've also memorized that the 440 tap drill is a 42. Somehow the number 440 and 42, they sit nicely in my brain together, so I've never forgotten that 42 is not only the answer to life, the universe, and everything, it's the tap drill for a 440 tap. I'm setting all my tap drills up in the drill press, which is just the way to guarantee that they're perfectly vertical. Know that I don't always do that. If I'm doing a quick and dirty build, I'll do everything with a hand drill. And some of it's not gonna be on point, but in the aggregate over a day-long build, if I'm tapping 30 holes, doing it with a hand drill as opposed to constantly doing it at the drill press is gonna save me sometimes well more than an hour of time. So I'm happy to give up the drill press, but for the straight and narrow, you wanna use the drill press. You want all your taps to be aimed in the direction that you intend. You'll notice that I took several passes to drill that hole in aluminum, and the rules for aluminum follow just like the ones for acrylic. You don't want your bit to get too hot, and you don't want it to start gathering up aluminum. What'll happen is when the steel gets too hot, it can actually gall, which means it can mechanically bond with the aluminum that it's drilling out, and then all of a sudden you've got this irregularly shaped bit that's hot and caked with aluminum, and all of a sudden it's making your hole not only bigger, but not round. Yeah, so for exacting work, like making a hole that you're gonna tap, you're gonna wanna just go gently. And again, some cooling fluid. I don't really need it for a hole like this on this setup, but it can't hurt. So I've got a 440 tap here. The first thing I'm gonna do is I'm gonna tap it wrong. I'm gonna put this in here, and I'm gonna aim to snap this tap. And you're gonna see how little force it actually takes. So I'm just going in. Okay, so now I've tapped that hole. That's gone pretty good. I can actually already feel that it's a little bit loose because this wasn't a spire point and I didn't allow it to push the material and I didn't go back, so I kind of got a little bit of a loose hole. Watch this. That's all that it takes. That was a piece of hardened steel. And in fact, the fact of its hardness is what made it so easy to break. Now in this instance, it just turns out that because the hole was a little looser, it's actually not that difficult for me to untwist that tap out of the hole. I'm here to tell you that a hardened tap inside a hole is its whole entire own nightmare. And there are things called tap extractors. I'm sure there are some people for whom they are useful. I have 2 sets here. I have never made tap extractors work ever at all. I had one mission critical tap break on a part that I literally could not rebuild. And I went in with a hardened steel point and I shattered the tap and shattered the point, but I was able to then kind of mostly pick the pieces of the tap out of the hole. That was the one time in my whole life, full of tons of broken taps in my past, that I was able to rescue a hole. The fact is, you just don't want that tap to break. Otherwise, things are really difficult. So let's re-drill another hole and I'll go really gently. Oh, it's a beautiful spire point tap. Once again, a liberal application of a bead of tapping oil. And I'm coming up to it. Now, here's something interesting, is that I'm tapping, but actually, look how far off of a vertical I can be. Watch this. I'm going to try and tap this off the vertical. Here we go. So you can see I'm about like 6 or 8 degrees off the vertical axis. And lo, I'm still being able to tap this hole. And you can see how much the tap is moving around. That's all. The reason it's moving around is because it can. And the reason it can is because I'm drilling off center and the tap is moving a bit. And all that movement means that when the screw goes in there later, it's got room to move. And room to move isn't great. It means it's going to rattle around. It's going to make its hole even wider. But like when I first started tapping, I didn't know that you could tap off center. Even a long, deep hole you can tap off center. So what's the answer? Yeah, see that? I've tapped that and you can clearly see that it's canted a little bit like this to camera left. And then, oh yeah, look at that. In this, in the Y direction, it's even worse. So what is the solution? I'm glad you asked. This. It's a key part of every young machinist's early tool making. This is a tapping guide block. This is a chunk of steel that a machinist on Bicentennial Man gave me and said, it's time for you to make your own tapping block. And all this is a chunk of steel with holes in it that fit most of these sizes of taps. And by fit, I mean specifically it fits the barrel of the tap. Okay, one last thing. When you're removing a small tap from a hole, you can see I've still got some material to pull out here. You can see how much this moves. If you're like torquing the tap wrench, again, you're carving material out. So at this point, if I have a real precise hole and the threading wants to remain sacrosanct, I'll take off the tap wrench and I'll undo the tap by hand. And this allows me, again, a finer control of keeping the tap from carving a new home. So here is This smallest hole fits the barrel, that's the fat part of this tap, and guides it so that it can't go off the vertical axis. So let's tap one and I'll show you exactly how it works. So I've got a little bit of tapping oil on my 440 tap. I'm going to feed it into my tapping guide block so it sticks out the bottom. There it is. Now I'm going to line up, there we go, the point of my tap with the hole that I'm tapping. Now I'm holding all this in orientation. My tap is in the hole I want. The tapping block is making sure it is perfectly vertical on the X and Y axis. And now because I've got a spiral point in here, I can actually just turn. But again, tapping is all about feeling how much resistance you're getting. So I might even recommend, if you really wanted to get to know this, is like buy an old tap set on Craigslist and tap some of these as practice until one breaks. It's really, really good to break one on purpose so you feel how much force, and each one's a little different, but holy hell, man, it's less than you think. It's really good to train yourself on that. Yeah, look under here, you can see it's coming through, and I am tapping a perfectly vertical hole in this material. There we go. Now that is an excellent and successful tap. So, the other nice thing about a tapping guide block is, remember how I said sometimes I pull off the tap wrench to undo the tap with my fingers? Because I'm using the guide block, I can actually pull the tap out just like this. Just give it a little spin, there we go, and it's out. Here is the hole that I drilled off center, and you'll see I'll put the thing in there, and you'll see how much, see that? That's not pretty. Not only is it not pretty, it's mechanically problematic. Like if you wanted to drill a hole through this and attach it to this, well, you'd have a vertical hole through this, but not a vertical tap. That's gonna cause you real problems later. This is why you wanna make sure everything's on the straight up and down. And now I'll put it in the nice hole that I just tapped. Oh, and the difference is, like this one rattles. When I get this one in a little bit, it doesn't rattle at all. It's really tight. It's just a little bit of movement, not nearly as much as there is here. And that is a beautiful mechanical connection. There's two processes which felt like magic the first time I did them. One was welding two pieces of steel together and realizing that they were now permanently affixed, like forever until some outside force acted upon them. That felt really amazing. The other was this, tapping a perfectly straight hole on both the X and Y axis and mechanically connecting two things that joined at the right way, at the right place and time. Feels magical. Feels like you're making a real thing, because you are. Okay, I know I'm forgetting. I would be remiss if I didn't talk to you about bottom tapping. Now we're gonna talk about the other main kind of tap, which is a bottom tap. And that's what you'd use for a blind hole. And I'm gonna show you what all that is. Now remember how I said that a tap works its way into the hole with its taper. So again, you can see the very tapered point of this, and then the fact that the thread cutting aspect is also tapered to allow the tap to guide itself into the hole. But let's tap this hole and then we'll talk about what's wrong with it once we've tapped it. Where am I at? Oh, not quite there. So now you can see one issue that's happening is the swarf, the cut from my thread cutting, is gathering up at the bottom of this hole. And again, when you have extra material going where it can't escape from, it could be problematic. So I'm gonna pull this out. I'm not quite done tapping this hole, but I'm gonna pull this out so I can remove some of that stuff. Okay, and we'll go at another pass of it. So this hole is called a blind hole because you can only see it from one side of the material. And this happens a lot mechanically. You have a part you can't drill all the way through, or you can't get to both sides for tapping. That is a fairly common occurrence. Okay, so I think I'm mostly at the bottom there. And if we pull this tap back out, you'll see the issue that I'm talking about. Right, the tap has a taper and the taper's in the hole so the threads don't go to the bottom of the hole. But they need to if this is going to be a mechanically sound hole. You don't want to put one of these in it, and when it reaches the bottom of its threads, what do? Do you just force it? If you did, this whole thing would crack. That's no good. That's why you need a bottom tap. And that's the next thing we're going to play with. So this is a bottom tap. And it's actually been cut really nicely. So this tap, as you can see how much different it looks, it's missing this whole taper, which means it can carry the threads much farther down. And you can't just start with a bottom tap. You have to start with a normal tap, and then you have to finish the hole with the bottom tap. This is a multi-step process because I got to keep clearing the material out, and you will want to as well, especially when you're working with metal. It's going to be a lot less forgiving, so you're just going to want to do this in several passes. The nice thing about a bottom tap is they honestly don't come up very often for me, but when they do, if I don't have one, you can take a normal tap that you've got and grind it. It's totally sufficient to do that, and I've done that many, many times. Okay, so I'm just going to carry these threads down a little bit farther. I'll feel them stopping. Oh, it's a good sound. There we go. I'm showing you this with the big quarter 20 tap, but all these rules apply to all the sizes. So now you can see that I have a much more mechanically sound hole because my bolt can go pretty much to the bottom of that hole. And that, my friends, is a bottom tap. So now I'm going to make a tapping guide block like this, but I'm going to do it out of clear acrylic, which is actually, honestly, I think a slightly better material. You can find this stuff sometimes in the scrap pile at Tap Plastics or a plastic supplier, or you can buy chunks of this off of eBay or even Amazon. It's a great time to be a maker because you can buy chunks of what would be expensive material that is offcuts from factory work. This 1-inch acrylic, it's extruded, which means it doesn't have the same melty problems that normal cast acrylic has. This is cast, and cast acrylic doesn't have the same thermal problems that extruded acrylic does. And I really like working with it because it gives you some nice finish edges. And also, for demonstration purposes, what you can see in it is fabulous. So let's make a tapping block out of some 1-inch acrylic. Whenever you're cutting stuff on a table saw, it's always good to make sure that the surface you're holding up against is smooth of debris, because one little knobby knob over here can throw your piece way out of square. So get your hands in there, make sure it's clean. It'll probably be about that thick. We'll go right through there. Yeah, okay, there we go. All right, so I'm going to smooth up the sides of this block. I'm going to use some 320 grit sandpaper, and I'm going to wet sand it. And what the wetness does is it allows the material you are sanding off to not gum up the sandpaper itself. It allows it to move a little bit. It just gives us a really nice, smooth surface. Your table saw table is a fantastically flat surface, and large flat surfaces are super useful for setting up and clamping and gluing and stuff. This table saw gets used a lot for this kind of thing. Okay. Before I get to the actual making of my tapping guide block, I think it's worth talking about why we have different thread counts depending. And for me, the number 10 size taps are the ones in which I am always making a delineation as to whether to use the 1024 and the 1032. This is a 1024. You can see it's got those heavier threads, and that's a 1032. It's much finer. That just means 24 threads per inch, 32 threads per inch. Which one would I use in a given situation? If I was tapping a piece of steel like this, I'd use the 1032. It gives me fine granular control. The closer threads allow me to do a wider turn to tighten it, and that's a nice amount of mechanical advantage I get on that. With the coarser threads, the graph for tightening is much sharper. It's a sharper hockey stick. With soft material, the opposite is the case. I wouldn't want to use a 1032 tap in acrylic because if I'm putting a mechanical load on those threads, and when you're putting a screw in there and tightening it, it's friction torqued against every single thread that it's touching. So you're putting that mechanical load on acrylic, it's going to fail on you. So in acrylic and softer materials like Delrin, I use the heavier taps. For the harder materials than this, like aluminum and steel, I use the finer taps. Within mechanical engineering, there's entire fields of study about this that really don't ever fall within the purview of making shit at home, but it's worth it to know it. Here's what we got, 2, 4, 7 taps, and I've got a piece of acrylic. I've put a piece of masking tape on the top as a guide so I can kind of map out where I want these holes to go, and I think I'm gonna line them up on one side. These are just guide holes, so their actual position isn't super mission critical. Like they can be slightly misspaced if need be. In fact, for this 1/4 I'm gonna go a little bit farther. So that is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. I tend to circle where I'm going to be drilling, because on the drill press, it just makes it really easier that I'm drilling in the circle. Okay, so this one is 0.14, and I bet this is the same, 0.14. Yeah, I think this is the same too, 0.14, and this is bigger. So first 3 holes are all the same. I'm gonna wanna go with a 0.45, 4, that's the one. 0.144. I don't want it too big, but I want it slightly oversized. So if I measure this, I get 0.144, and this is 0.140, an extra 4 thou. It's the difference of a piece of paper, which is about 4/1000ths of an inch, or the thickness of your hair. Yeah, pretty much. So that's the 144. That is the number 27. Now we move up, and that's a 165, and this is, nope, that's bigger. Okay, so I want 166. I want something slightly bigger than that. 169. Ooh, did you see that? You see how that grabbed it? That's one of the particular things about regular drills that's rough on acrylic, is that this drill has these flutes, and at the bottom, it's cut at an angle, and that cutting angle is moving around, and it's pulling itself into the work, which means the moment it breaks through the bottom, it yanks down and then pulls the material up. And that can cause stuff to shatter. It's not something I'm super concerned about with this acrylic because I'm familiar with it, but it can really ruin your day otherwise. So it's a good idea to clamp stuff down. That's why it's happening. Okay, next drill. So now, this is 0.19, 0.196. If this seems tedious, it's totally tedious. I've made lots of these things and they always are kind of a slow and plodding build, but at the end of it, when you end up with a thing that you built that makes your life easier, those are some of the loveliest tools to have floating around your shop. I've had that tapping guide since 1998. 1999, Bicentennial Man. That's where I got that one. Okay, here we go. I'm almost all the way through here, but I want to show you a little technique. If you want to stop that kind of grabbing, like when I break through the bottom of this is going to want to go up like that. And that's when it could shatter, all sorts of bad stuff could happen. So what you want, perhaps, is a bit of a frangible piece of acrylic to go underneath it. And you'll see this breaks through, but because there's another piece of acrylic underneath it, it doesn't automatically drag everything to the top. And that's how you eliminate that problem. Barrel of this is exactly 0.254. So I'm going to want to go slightly oversized to a quarter inch bit. Yeah, we'll go with 257. An F drill here. Lovely. All right. Let's try out our tapping block, shall we? I'm going to use a 256 tap. Two 56, 4, 40. 6, 32, 8, 32, 10, 24, 10, 32, quarter, 20, 1, 2, 3, 4, 5, 6, 7. Just to complete this build, we're going to use the tapping block, but first we're going to label it with an engraver. Always good to do a little test piece in a piece of material you don't care about. This piece, and I'll work on top of it. Yeah, that's it. That's what I wanted. Just like that. All right, here we go. Yeah, a little grease pencil inside the engraving. I think this might make it stand out quite nicely. Or it could just be a total wash. Hard to say. Let's see here. Obviously, you can laser cut these labels. You can do it however you want. Ladies and germs, I think that's a respectable tool addition to my shop, the Savage Tap Block. Right, we drilled a hole in order to use this. Here we go. This is a 256. There is the 256 guide hold. You can see it holds it really nicely with almost zero chatter. It's only about 1/4 thou over. I'm lining it up with my hole here. Oh, right. Do a little tap magic going on. Boop. And here we go, ladies and germs. Now, I'm just holding that nice. Oh, nice. Might have gone with a slightly oversized drill bit on this one because it's going quite nicely. There we are. So let's just test that out with a 256 screw, machine bolt. And there you have it. Look at that. Absolutely perfect. And like I said, for a couple of hours work, this is a tool that will live in your shop and work with you for the rest of your life. And those are, like I've said already, my favorite tools. Oh, I almost forgot. You might have been wondering this whole time, how do I look up which drill bit goes with which tap? And the answer is there's a chart, and it's in your Pocket Pal, it's online. But my recommendation is to find a guide like this, a handy little guide that shows you all the tap sizes and the drills that go in them, their decimal equivalents, etc., etc. This is an invaluable thing to have in a shop. Lots of people have them as posters up on the wall. You can find them online, you can print them out, you can make your own, you can laminate them, but you should have a hard copy. Frankly, that definitely makes things go faster. Thank you so much for watching that entire video. Your viewing helps us keep the lights on. Well, it's one of the ways. One of the other ways is through selling our merch. And you guys have been so fabulous about suggesting great merch ideas when I say something strange or funny, and you suggest in the comments that we put it on a sticker or we put it on a t-shirt. Well, we are following your advice. And if you follow the links below, you can buy some of our merch so that we can make some more videos. Thank you guys for watching.